All right, so here we go. Now I'm kind of going to start by explaining why the tangent graph was heading towards the positive as on the kind of the right side of zero, and heading to the negative on the left side of zero. And so what I've done here is tried to, and they're both pretty ugly, but I've tried to graph cosine here in green and sine here in blue. And so let's talk about this a little bit. And I know it's going to be a busy graph, but I really do think this would be helpful if you try kind of understand conceptually what's going on here. So again, have overlaid sine and cosine graphs on top of the tangent graph. And so right at zero, what is sine or the tangent is going to be equal to, or we can even color code this, that might be more helpful. The tangent is going to be equal to sine over cosine. Sine over cosine. All right, so then where here at zero, sine is 0. So 0 divided by 1, that gives us 0. That's why tangent here is 0. We talked about that. At pi over 2, sine is now 1, but cosine is 0. So 1 divided by 0 gives us our asymptote. That makes sense. We talked about that already. But now let's get into the why is it heading up towards the positive and why is it heading towards infinity? So if we went just a little bit to the right, maybe say let's pi over 4, for example, somewhere right in here. They look like that. Well, if it's at pi over 4, that might be where these two cross, and that would make sense because the pi over 4 is where we have our 45, 45, 90 right triangle, and so the legs are equal to each other, and so whatever this value is, then it's exactly root 2 over 2. But root 2 over 2 divided by root 2 over 2 gives us 1. So tangent should be exactly 1 right at pi over 4. Exactly 1. And then every pi added to that. So 5/4 pi and so on and so forth. Likewise, if we went negative a little bit, like negative pi over 4, these two values, now we would have the cosine graph being positive root 2 over 2, sine being negative root 2 over 2, and when we divided those two values, we should end up at negative 1. And so our sketch is well, it's a little bit off. It should be coming down a little bit faster here. But tangent would be exactly equal to negative 1 at negative pi over 4, because that would give us to our 45, 45, 90 right triangle. And those two sides would be equal in value other than sine being negative. All right, now why is it heading towards the positive? Well, we've got 1 point, so that actually should be enough of a reason, but let's be a little bit more explicit about it. So here we have, as we are heading closer and closer to the asymptote, notice what's happening with sine. Sine's getting closer and closer to 1. That's not a huge value, but it's getting closer and closer to 1. While cosine, notice it's getting closer and closer to 0. Its output's getting closer and closer to 0. As it gets closer and closer to 0, it's dividing that number. Let's just say that it's 1. It's approaching 1. It's going to cut it into smaller and smaller and smaller pieces, and as we're maybe the cosine, maybe right here the cosine would be something like 0.0001. 1 cut up into that many pieces gets to be 1,000. Remember, it's not quite 1 at that point, but it's close enough. And so this is going to be way up here. It's getting very high, very fast. And as it continues to get closer and closer to 0, it's going to cut it into smaller, smaller pieces. Now, just after the asymptote, notice where cosine is now. It's still incredibly small on this side right here, but these values are now negative. So where it's sine is now on the downhill slide of being at 1, but it's still close to 1. It's now being cut into incredibly small negative pieces, or cut up by incredibly small negative pieces, giving us negative infinity. So it's getting cut into all these tiny little pieces, and they're negative, so we're starting from the negative and coming on up. And that gets repeated over and over and over. Now let's use that to help us flesh out cotangent. So at cotangent, remember, is the reciprocal of tangent. It's going to be, now let's keep our color coding here. It's going to be cosine divided by sine. Cosine divided by sine. We'll have, so where, let's start with kind of where will we have, we'll do cotangent in red again. We'll try orange. We'll give it a little bit different. Where will cosine be 0? And so it's going to be 0 at negative 3/2 pi. So we're going to have a 0 there. Cosine is 0 at negative 1/2 pi. It's 0 at 1/2 pi. And it's 0 at 3/2 pi. All right. Now where will there be asymptotes? So that's going to be where sine is 0, because now we're dividing by sine. And notice sine is 0 at negative 2 pi. So there's an asymptote. At negative pi, another asymptote. At 0, so right along the y-axis here, we have an asymptote. At pi, and at 2 pi. There's our asymptotes. Now it's going to be, hopefully that kind of cues you in. It's going to look very similar to the tangent graph, but let's figure out kind of some points from there. So where is cosine? Cosine divided by sine. Hey, this is still going to be 1 because we have positive 1, positive, these two values, remember root 2 over 2. Divided by root 2 over 2, and they're both positive. That's still going to be a positive 1 right here at pi over 4. And as we go to negative pi over 4, now we'll have sine being negative divided by its equivalent value of cosine. That's going to be negative 1. So those points are the same. But notice that the difference between this graph and the other graph is that before we had a 0 value here at the axis, now we've got an asymptote. And so if we were to, hey, what side is it going to be approaching? And hopefully you can just see now that, hey, it's going to have to go through 1. It's going to be approaching from this side right here. Let's do, well, as it's approaching from the positive side of 0, cosine is getting closer and closer to 1, while sine's getting closer and closer to 0. 1 divided by infinitely small pieces, but positive, heads towards positive infinity. Likewise, coming down and heading towards negative infinity. On the other side, so approaching 0 from the negative side, we'll have cosine being close to 1 and sine being close to 0, but infinitely small pieces, but they're negative because it's now below the y-axis. And so those are going to be negative, coming from the negative, and again heading towards the positive. All right, and you can see it's very similarly shaped. There we go. And so each of these, and we never did write them in. Let's go and put this one actually in degrees. This is 0 degrees. This is going to be 90 degrees, 180 degrees, 270, 360, and negative 90 degrees, negative 180, negative 270, and negative 360. All right, and let's graph it real quick on our calculator. So y being equal to 1 divided by tangent of x, or of theta, and graph that up. And there it is. You can see it's falling from the positive to the negative, from asymptote to asymptote. And so it looks very similar, but it is obviously a little bit different there. So period's the same. It's still going to have a period of pi, or 180 degrees. Its amplitude still going to be none with those asymptotes and heading to positive infinity and negative infinity. We can't calculate infinity minus negative infinity, so we just consider it to be none. Domain, this time theta cannot be equal to 0. And then if we're thinking of it in radians, so plus n times pi, plus n times pi, or can't be equal to 0 plus 180 degrees times n, and again, n being an integer. And range, we can get any output we want. We're heading from infinity to negative infinity, so range is all real numbers. All right, hope that helped.